Thank you and good morning everybody. I'm Giovanni Lugaresi from Politecnico di Milano and I'm going to present the joint work with my supervisor Professor Andrea Matta. In this work we are going to present the experience of a remote laboratory that we did in the last year as a substitution for the in-lab activities for a discrete event simulation course. In this course we teach discrete event simulation, and to improve the teaching effectiveness we have designed Lego-based manufacturing system models with which the students can interact and perform the activities that are required in the course. Here is a short table of contents, but I think I can go towards the contents directly. As a short introduction, basically this work has been motivated by the fact that the students rarely deal with the real systems to be observed and modified. So, and there is a difference, a significant difference with the real industrial project and the projects that students usually deal with the frontal lesson and with the frontal lesson experience. So in the last years there has been a lot of contributions in the literature pushing towards a more practical approach and giving the students the possibility to experiment and to take risk and test their approaches directly in a real environment. I think that this is very well known within this community, so I think I can also go further. The motivation is very clear. To cover this gap, we have been inspired by the literature and by some approaches in which some authors designed manufacturing system models directly with the Lego components. By building the components with Lego, they can recreate the dynamics of real manufacturing systems with respect to material flow. So the main goal is to recreate the dynamics of a system, for example, with respect to policies, scheduling policies, trajectory planning, and routing and optimization of the production plans. So we have been inspired by these works, and we also developed a laboratory in which students can experience the manufacturing system dynamics with such models. So here it is one of the models that we have developed. I see also the videos. There are stations are built with and we can recreate the dynamics of a real system. Basically we can recreate the material flow, we can build a real manufacturing system. We have applied this laboratory experience in a course which is part of our offer in Politecnico di Milano. The course is called Integrated Manufacturing Systems, and it is part of the master specialization, so the production planning master course in mechanical engineering. In the course we have several activities. We have lectures of theoretical aspects, and we teach discrete event simulation as a tool for analyzing manufacturing systems. We also provide classworks in which students can use state-of-the-art software, so they can learn the tools, and laboratories in which they can make experiments and practice. Within the laboratories, the students are also asked to perform a project work in which they are given a realistic instance of a problem, and they can work in a group and try to solve a realistic industrial problem. The project work takes around the effort-wise around 50% of the effort required in the course. So here are some more details about the project work, which is the focus of this work. The main goals is basically to learn the main elements of manufacturing systems, to be able to grasp the complexity of such systems, for example, with respect to different part types and different scheduling policies which might impact on the system performance. Then they are also, the goal is also to be able to integrate knowledge of other courses. So the students are free to propose approaches, also to self-study and apply approaches that we do not teach directly in the class. And of course, we also give a good space to the group work so that they can develop also soft skills and communication skills and all the skills that are typically developed when people work in a group. So what activities they do, they used to do in a lab. In a lab they can come, they could collect the data, retrieve the information from the system, also from simple observation, ask information also to the trainers, which are myself and my colleagues. And then they are also asked to analyze and estimate the performance of the system and to propose some improvements with respect to a certain industrial problem that we change every year. In the lab, they also have the opportunity to test their improvements, so to implement their improvements and to test them directly and see if their hypotheses were right. Traditionally, this project work has been done in the lab physically, and as you can see from the pictures. Unfortunately, the last year, as you well know, we had to switch to a remote experience, and in this work I will show how this experience has been done, in particular focus with the project work. So here is the outline of the experience. Basically, we switched the visits that they usually were used to come to the lab and do. We switched to a virtual visit. So they can, the students can come virtually to the lab for a couple of times. The first time is for a simple observation, and then they can also collect data from the system. Then they are asked to perform this a self-study, so the part of the work has to be managed by themselves. And then they have the opportunity to come back to the lab, still virtually, and perform the implementation of their approach, of their proposed solution. In this year, so the last year, we designed a system in which it is schematically represented here, which we have 6 stations. 2 of these stations are supervised by operators. And we have designed a problem in which the operator has to move. An operator has to move between 2 positions, and if the operator is not in the position of the corresponding station, the station cannot be repaired in case of failures. So the goal of the improvement was to propose a system policy based on the state of the system. The students were asked to provide an action table so that the operator could know in which position to go as a preventive positioning of the operator. So, of course, as I was saying, we had to design a remote setting. This is a sort of recap of how the setting looked like in the remote way. We had to install some cameras in the system. We installed the 3 cameras so that we were able to give students both an overview of the system and a closer look if they needed to. And then additionally, we also designed a dashboard that is done with state-of-the-art tools, which is able to give the real time state at any time, and the students can access and see the real-time state of the machines, the production levels, the buffer levels, and the throughput, for example. So with this tool, they were able to have a better idea of the real system behavior. Here it is one of the possible views that they could experience from their side. They could select to watch the dashboard and one of the cameras that we installed in the system. So here is when we perform the lab, how the experience change. We tried in the paper, we tried to give some considerations of our experience this year and to draw some preliminary conclusions. I'm going to just comment on some of these points. We think that the experience with respect to the observation of the system and to the data collection of the system was quite comparable to the experience of the previous years. This is also thanks to the setting that we provided and the possibility to dedicate time on the important part of the data collection and observation. And so we think that this can be considered quite comparable. In other aspects where we spotted more differences with respect to the previous years. For example, with respect to the modeling, when performing modeling activities, the groups in the remote setting, they used to they were less careful in the selection of a modeling level of detail, and they had the tendency to model everything with the same level of detail. This is perhaps due to the fact that being in a remote, it is harder to and it takes more courage to not consider some aspects because of the fear of missing some aspects of the system. Then we also this aspect also impacted on the tendency to be more quantitative in the analysis, because, for example, in the input analysis, in simulation input analysis, they had the tendency to consider all the data and so this was actually a plus because they could be more objective in the input analysis. With respect to the solution implementation, however, I noticed that in this year, being in remote, the activity was far less engaging, of course, because they could not have the opportunity to come to the laboratory, and with the remote experience, with the camera experience, they could not spot exactly and very effectively the difference in the system performance. So the activity was less engaging, and some of the students considered it almost useless for the goals. So these are some of the comments, and you can find other comments in the paper. As a conclusion, so this is an initial comments on the experience being remote. We think this experience was useful, and we will keep some aspects of this experience. Hopefully, we will be able to go back to host students in the lab, but we can keep part of our setting. For example, the ability to have a real-time dashboard and a real-time database which students can access and take the data whenever they want. and the ability also to record and see the system working for several times also when the students go back home. In the future, we plan to, of course, extend the new projects. We do one per year, typically, and we typically change the type of manufacturing system that the students need to analyze. And we also think that being in a, if we had to come back to a remote connection, we can also try to implement some of the approaches that the colleagues showed before. For example, the direct remote connection to the components of the system, so to let the students directly modify the behavior without without a supervisor assistance. So thank you very much for your attention, and if you have any question, I'm available. Thank you.